Here we're asked to write an equation for the inverse and verify using composition. So first one here, I'm going to switch x and y, and I'm going to now solve for y. So subtract 2 from both sides, cube root both sides. So I got cube root of x minus 2 equals y minus 3, and then add 3 to both sides. So my final inverse here will be the cube root of x minus 2 plus 3. So there's my inverse for the first one. I'm going to use composition to make sure that that's actually true. So I'm going to take this here and plug it in for x. So when I rewrite this, I got cube root of my original function, x minus 3 cubed plus 2. And then that's minus 2 all inside the cube root, and then plus 3 on the outside. So when I simplify this order of operations here, what I should see is, 2 minus 2 is 0. So I got cube root of x minus 3 cubed. Then these cube root cancels out the cube part, so I'm left with x minus 3 and plus 3, which negative 3 plus 3 is 0, and I end up with just x, which means, yes, this is in fact an inverse. For the second one here, again, switching x and y. I'm going to multiply y plus 1 on both sides because I want to get y by itself. So first I'm going to distribute and then get all of the y's that I have on the left side. So I'm going to subtract 2y, and I'm going to move this x over to the right side. So I got xy minus 2y equals negative x minus 1. Now my greatest common factor here is y. So I got y times x minus 2 equals negative x minus 1. And now I'm going to divide both sides. So I'm going to pull the negative to the outside here. X plus 1 over x minus 2. Now again, I could leave it as just negative x minus 1 over x minus 2. Either one really works. It doesn't really matter. I just think this one looks nicer. Okay, you're going to now verify here. So I'm going to plug this back in. This is going to get maybe a little bit ugly, so let's move it to the side here. So from here, I plugged it in. I distributed this negative here, and now I'm going to get rid of the denominator by multiplying the top and the bottom by x plus 1. So when I do that, what I should see is that I'm going to distribute, and I'm going to distribute. So what I end up getting here is negative 2x plus 1 minus x plus 1, and then 2x minus 1 minus 2 times x plus 1 here. So now I'm going to distribute this negative 2. I'll get negative 2x plus 1 minus x minus 1 all over 2x minus 1 minus 2x minus 2. And so when I start dealing with this here, once I go ahead and combine like terms, these cancel out. I get negative 3x here. Then I get 2x minus 2x cancels out. I get negative 3 here. Then I cancel out my negative 3's, and I'm left with just x. And therefore, after all that work, I did verify that this was my inverse.